So we might have an exponential model that looks like this. Y equals A, B to the X, where the base is just some base that we have. We would, in science, a lot of times we prefer to have that base be E. So how can we convert it? We actually did this in another video, but let's just show you. What we're trying to get is a model that looks more like our exponential model, A naught E to the KX. We'll keep it in terms of Y and X. Okay, so we're trying to convert from this model over to this model so we can have a base E. So we can use natural logs and everybody's happy. Okay, so they give us this model here, and you have that 2.5, that's like your A, and then this is your B, 3.1 to the X power. So we don't want that B to be B. We want it so that the same function is written in this form. Okay, and the way to do that is use your inverse property of logarithms. So e to the natural log of x is just equal to x. So this is like a side note. This is a property that we had. So what we're going to say is e to the natural log of 3.1 is equal to 3.1. Because the 3.1 is what we want to get rid of. So we're going to replace the 3.1 with this. So that's going to look like y equals 2.5 times e to the natural log of 3.1 to the x power, right? Okay, so I'm just replacing 3.1 with this. Now we could go the other way and say, hey, e to the natural log of 3.1, isn't that just 3.1? Yes, but we're trying to get rid of that 3.1. We're trying to get it in terms of a base e. Okay, so then what do we do here when we have power to a power? We multiply them. So I'm going to have 2.5 e to the natural log of 3.1 times x. Now, that's going to be our form, and that's exact. We know in our heart that we could find the natural log of 3.1. We could get a decimal approximation for it for that constant k. But we just have an exact answer here. So, all right. So those won't take very long to do, but that's what's going on.